So we're talking about operations on polynomials. Operations, I don't know if you've seen a trend with this, but every time I say the word operations, it usually means that we're talking about adding, subtracting, multiplying, and dividing. Today, we are only talking about adding, subtracting, and multiplying radicals. When it comes to adding and subtracting, there are some rules. There are some rules with multiplying too, but they're different from these. So we're going to start with the adding and subtracting rules and then do some adding and subtracting problems. And then we'll talk about the multiplying rules and do some multiplying problems. Rule number 1, let's go steps. Steps. It's not even rules, it's steps. Number 1, simplify all the radicals. Step 2 is long. Identify radicals with same index. And I'll give you a reminder of what the index is in a minute. And same radicand. And same radicand. Because they're the only ones that can be combined. They're like terms, right? Like I can't multiply an x times an x squared or add an x to an x squared. I can multiply an x times an x squared. I can't add an x to an x squared. In the same thing, I cannot add a square root to a cube root, right? For the common radicals, that means for where they're same, for common radicals, we can add or subtract the coefficients. Coefficients, if you remember, are the numbers out in front of variables, right? They're just numbers. And then you keep the common radical. What does that look like in real life? Well, if I was looking at it in terms of a problem, starting with, say, 3 times the square root of 27 minus 2 times the square root of 12. Well, when we look at this, we have to break down these radicals. Remember, it says to simplify them, which means we need them in their simplest form. And so the square root of 27 is breakdownable, right? If I look at 27, 27 is 3 times 9, which is 3 times 3. This being a square root, as soon as I have a pair, I can pull a 3 out. Once I pull this 3 out, though, I still have this other 3 left. And so this is going to be 3 times the 3 we pull out. But back underneath here, we're going to have to put that remaining 3, right? Minus, well, here I've got 12, right? It's going to be 2 times something. Let's figure out what we've got here with 12. 12 is 2 times 6, which is 2 times 3, which means that I can pull out a 2, right? So we're going to do that. We're going to write times 2. But this 3 that's unmatched is going to have to go back under. This isn't the first time you've seen me break down square roots, right? We've done this before. 3 times 3 is 9 rad 3 minus 2 times 2, which is 4 rad 3. Now notice these are the same. These are each square roots, so they have the same index, which is no index for us because we don't put an index for square roots. And this is radical 3 over and radical 3, which means that I can combine these like terms. If these weren't the same, right? If these weren't the same, we could not add or subtract them. It's sort of like having a common denominator. You can't subtract them, add and subtract them if they're not the same. So, but here we can go 9 minus 4 is 5. radical 3. And that would be our solution. Does that make some sense? I'm going to need a yes or no. An eh? Okay, eh is fair. All right, we'll see more of them. So this isn't your only opportunity to get it on this one problem. What might help is if I change the color of the pen that I'm using. That's usually a big help. Not really. That's not really a big help. What if I have, let's go 3 times the cube root of 54 minus 2 times the cube root of 2 plus 7 times the cube root of negative 16. So there's a lot going on here, right? 3 pieces, but they're all going to each break down the same way. Notice that they are all cube roots. If they weren't cube roots, we could not combine them, right? Because I can't combine a square with a cube. But as long as this index right here is 3, 3, and 3, we're good to go. Now, we have to have a common radicand underneath here, right? So we're going to look at each number and we're going to break them down as simply as we can. So the first one, we got 54. Now think about this. This is a cube root, which means that something there has to be 3 of something now to pull it out instead of just 2, right? So we're going to start here with the 3 we've already got. We're going to see what we get here. Now this 54 is an even number, so I'm going to start by dividing by 2 and seeing what I come up with. So it's 2 times 27. And then 27 is 3 times 9, and 9 is 3 times 3. So I have 3 3s. So I can pull a 3 out. So I'm going to go times 3, and whatever's left, which is this 2 right here, is going to come underneath. Now, I cannot make this right here any smaller than it is, right? This is a 2 underneath. There's nothing to break down. So this is going to have to stay minus, oops, I forgot the 2, minus 2 times the cube root of 2, right? Can't make it any smaller. I can't reduce a 2. Then we've got plus 7, and now we've got negative 16. And then if you think about 16, negative 16, we can have a negative, and we're going to pull a negative out. Because it's a cube root, we can have a negative underneath without it being an imaginary number. Because if you think about, if I multiply something, like say I have negative 2 times negative 2, that equals 4, right? Positive 4, which is where we would come in with that imaginary number. But if I multiplied it times another negative 2, that gives me negative 8. And so we can have negatives underneath a cube root. So we're going to look at negative 16. And we're going to go, okay, well, that is 2 times 8. We could say negative 2 times 8 if we want, which is negative 2 times 4, which is negative 2 times 2, right? Because it has to only be 3 of them. So I can pull a negative 2 out of these, and I'm still left with a 2 underneath. So times negative 2 radical 2. And so now we have all of these matching radicals, right? We have cube root of 2, cube root of 2, cube root of 2. And so this would be 3 times 3. That's 9 times the cube root of 2 minus 2 times the cube root of 2 plus, oops, sorry, not plus. 7 times negative 2 is negative 14. times the cube root of 2. And since all of these are cube root of 2, cube root of 2, cube root of 2, we can just add and subtract their coefficients. So I can go 9 minus 2 is 7. Minus 14 is negative 7 times the cube root of 2. Does that make a little bit of sense? A little bit? Okay. There isn't a lot more to the adding and subtracting of these things, but I will do one with a variable in it or some variables in it just so you can see how they work so you don't get surprised when you look at the homework sheet. You'll have to bear with me because I haven't done this problem yet. But luckily it's a square root. Man, they are loud outside my room today. 98x to the 4th y squared man, they are so loud. Minus 3x squared y, x squared y radical 2. All right, so this is what we've got so far. There are things I can look at here. The first thing I need to look at is this 98 under the square root. 98, the square root means I only need to have 2 of something to pull it out, right? So let's look at what we've got here. I don't know all of my roots to 98, but I know that it is divisible by 2. 2 goes into 9 4 times. See, that's going to be 49. Then 49 is 7 times 7. That's convenient, which means we can pull a 7 out, right? But that 2 is going to have to go under. So we'll go 7. How many x's can I pull out? I've got 4 x's, so I could pull out x squared. I've got 2 y's, so I could pull out a y. And what's going to have to go back under is the square root of 2, because my 2 here had no match, right? And so now I've got minus 3x squared y radical 2. Well, look at this. This is 7x squared y. This is 3x squared y. So we got that radical 2. So we could just go ahead and subtract the coefficients. 7 minus 3 is 4. X squared y radical 2. And that's going to be about as hard as it gets when we're dealing with the adding and subtracting of these. But we still have to talk about multiplying. Multiplying, I think, is easier than adding and subtracting. Just like when we're dealing with fractions, like when we're adding and subtracting fractions, we have to find a common denominator. It could be a pain. But when we're multiplying, we just multiply right across and then reduce. It's fairly similar in that respect. And we aren't even talking about division today. So, freedom. When we're multiplying radicals, step number one is we want to multiply the coefficients. And then use the property rule. And the property rule is the one, if you remember the property when it comes to radicals, if we have times b, we get n to the a times b. And then 2, you just simplify the radical. Simplify. What does that look like? All right. If I have, for example, the square root of 27 times the square root of 5, I can just make that the square root of 27 times 5, right? Which gives me the square root of 135. And now, right, so I multiplied everything together. Now I just need to simplify. So I've got 135. I know that that is 9 times 15. And 15 is 3 times 5. This is 3 times 3. It's a square root, so I can pull out 2. 2 of the 3s, I should say. 3. And I'm going to be left with 3 times the square root of 15, right? These 3's come out, but these two things have to go back in. So we multiply them together. So not terrible, right? What about if I have 2 radical 3 9 times 5 cube root of negative 24. So I can't reduce this anymore. 9 is just 3 times 3. I can't pull 3 of anything out of it. So this already right here is at its basis form. We can't reduce that anymore. But we do have to look at negative 24. I don't know why I'm writing 25. Negative 24 and see if there's anything we could pull out of there. I'm hoping it's going to leave us with a 9 underneath it. But, I don't even know what I'm doing. I'm multiplying. 2 times 5. 2 times 5 is 10. Right? The cube root of 9 times the cube root of negative 24, I can write like this. 9 times negative 224 is negative 216. So I have 10 times the cube root of negative 216. Now, you can believe me or not believe me, but I can tell you that 6 times 6 times 6 equals 216. Therefore, negative 6 times negative 6 times negative 6 equals negative 216. And so what this is going to leave me with is 10 times negative 6, or negative 60, as my solution. I want to do something harder before we get to the end of it. Let's look at one with some letters in it. If I have, for example, the cube root of negative 3 to the negative 3a to the 7th, b to the 4th, times the cube root of 36a to the 6th, b to the square, b squared. When we multiply those, we're going to get the cube root. Negative 3 times 3 is negative 9. A to the 7th times a to the 6th is a to the 13th. Remember, you just add the powers when you multiply. b to the fourth times b squared is b to the sixth. And now we can start reducing. That -9 can't come out. Nothing times itself 3 times equals 9. Oh, that was 3 times 36, not 3 times. Did you see where I screwed that up? It's -3 times 36. What is that? -3 times 36 is -108. So I'm just going to rewrite that. -108, a to the 13th. Cannot do this today. A to the 13th, b to the 6th. Right? Does 108 reduce? Does -108 reduce? Probably. Right? I don't know. Let's look at it. 108, it's divisible by 2 for sure. That's going to be 54, which is divisible by 2, which is 27, which is 3 times 9, which is 3 times 3. So the 3's come out, but the 4 has to go back under. So here we're going to have 3. Let's look at what we can pull out first. So I can pull out -3. A's, for every 3, I can pull 1 out, right? So I've got 13 of them. So I can pull out 1, 2, 3, 4 sets of A's. So A to the 4th. 6, for every 3, I can pull 1 out on B. So B, I have 2 sets of 3, so that's B squared. And the only thing that's going to be left underneath is this 4 that we were unable to pull out. And one of the A's, right? I had 13, I could only pull 12 out, so I still have an A left. Right, when you're looking at the A's, think about this. I have 13. For every 3 I can pull out, right? So 3 times 4 is 12, but that leaves me a remainder of 1, and that one's going to have to go back underneath. I hope that made some sense because I don't want to do anymore. It's getting a little late in the day. We only got a few minutes left. Oh, no, we got plenty of time left. Class doesn't get out to 1:08. The only other thing I'd want to show you that I'd want you to have an example of is if we are multiplying a binomial, like a number times a binomial or a binomial times a binomial, and how that would play out. So say I have, for my last example, the final example of the day, 6 radical 6 minus 6 radical 2 times radical 6 plus radical 2. This is going to work just like anytime we multiply any binomials. It's just our numbers are going to get a little crazy and we're going to have to reduce them. So we're going to start. We're going to start by taking this piece right here and we're going to multiply it by each of these. So I'm going to go 6 rad 6 times radical 6. So that's going to be 6 times radical 6 times radical 6, right? And we'll figure out the math part of that afterwards. And we're going to go 6, right, plus 6 times radical 6 times 2. And then we're going to go here, we're going to go minus 6 times radical 6 times 2. And then we're going to go minus 6 times radical 2 times radical 2. And if you notice these two end pieces, The square root of 6 times 6 is just 6. So this becomes 6 times 6 plus 6 times the square root of 12 minus 6 times the square root of 12 minus 6 times 2. 6 times the square root, 6 times 6 is 36. 6 times the square root of 12 minus 6 times the square root of 12, those just cancel, right? They're just 0. Minus 6 times 2, well, that's minus 12, which equals 24. We wound up with 36 minus 12, which equals 24. So when you have these binomials, will they all cancel out like this? No. Sometimes you're going to still be left with square roots. But just remember, FOIL them through, distribute, use your distribution. That is all I can think of to tell you. Your assignment is a worksheet. The worksheet only requires that you do the odd numbered problems. But if you don't follow the instructions and do all of the problems, then, well, you'll have learned more for not following the instructions. That's really all I've got for you today. Does anyone have any questions about any of it? Or do you have plenty of questions about it and you don't even know where to start with your questions? Well, since I'm getting a sea of no's here and no yeses, I'm going to assume that you guys are good to go. If you start doing it and you run into some struggles, let me know. We can always pop into a meet and go over them. But otherwise,